I'm going to be going over problem 4, the line of best fit graphing for this problem specifically. Dr. Sparks' video is a general problem. I'm just going to be going through this problem specifically, like I said. So you're going to want to start by plugging in your data. So I just copied and pasted it into R and E. You can type it in by hand, copy paste, whatever. It should look like this. Yeah, that's the data. So in the C column here, we are going to have the line of best fit. You don't have to type this out, but I do just so I know what to plug in below it. So we're going to set this equal to the interatomic equation, which we know. I like to put in a lot of parentheses just to be safe. Let's see. Negative A over R plus B over R to the power. And because we're given that n is 8, you could even just change this to 8. I'm going to leave it as n just so you can see how we're kind of going to plug the variables in. But because we know it's 8, you could just put it in as 8 here. You'll get the same answer. So then we have our variables down here. So we have A, B, and N. Like I said, you don't necessarily need N. N is 8, and then for A and B, we're just going to start by having each of these 1. You could use any value, but 1 is generally a good number to start with if you have to guess. So then for this line of best fit column, we want essentially to solve this equation using our R value over here, whoops, and then the variables we determined down below. So we're just going to plug that same equation in, but instead of typing a negative A in, I'm just going to click my 1 that I assigned to A. And then instead of typing R in, we're just going to click the R value for that row. And you're going to do the same for B. So you're going to have click B divided by R power of n. Like I said, you wouldn't click the n if you just put 8. You just put 8. So then we have this formula that plugs in all of our numbers. And if you click enter, it'll give you a number. And so on Excel, if I were to click this corner right now, it would plug it all in and it would look about correct, but we want to keep our A and B values constant for this equation because it's a variable that we set. So to do that, we're just going to put a $ in between A35 and B35 and C35. That's because those are the variables we set. We do not want those to change. The A2 variable we want to change as it goes down the row or down the column. So for example, let's see, enter. So it gives us this answer, and then you can double click the little X in the corner and it should drag your values all the way down. So these values all change because we have our A, these values changing because we didn't put a $ before the A column. All right. So once we have that down, we can insert a plot. Just go to insert. I would recommend a scatter plot. You could also do line. I just tend to generally like these ones better. I would change one of them to a line. You can just double click the plot. So it'll let me do that here. Nope. It's thinking. There we go. Line. I'm just going to mark that as a solid line. This is our line of best fit. The E is going to be our data. So we're just going to set that to a line. The other one, I'm going to change the color so it's a little bit easier to see. And I just like making them both lines. You don't have to. I just like the way it looks better. Alright. So then we have our graph, and we have our data. So these two lines obviously are not overlaying each other very well right now on this graph. So what we're going to do is we're just going to change our A and B values. And it's kind of taking a guess. I would just leave A as 1, B is usually smaller than A, so we're just going to do 0.1, see what that gives us. And that changes our values a little bit, not very much, so I'm going to try again. And then you can see this curve starting to form the more we change our B value. So there it goes again. So that looks pretty good. I'd say that's with that B value, not bad. But we want to try and overlay it as best we can. So to do that, we're going to need a residual. And I'm just going to set that up here. And we also use a residual squared. That's just to basically double check that you are minimizing your value. So we want our E value and our line of best fit value to be as close as we can get them, because that's what we're graphing. So to do that, we are just going to do the residual is equal to our E value minus our line of best fit. And that's going to give us, if you click enter, it should give you a value. Double click the corner, it should drag it all the way down. That gives us the difference between the values. As you can see, the values get really small down in here. That's where it's crossing in here. And then the residual squared is just double checking. So right now, our residual up here is really high. It's like 5. Residual squared would be even higher. So the program wants to try and minimize both of these. So residual squared is going to be equal to our residual squared. And see, that's a pretty big value. So it wants to get the smallest value it can. We are also going to do the sum of our residuals, kind of as a third, I guess a third measure, just to be safe. We're going to equal that to our sum of the residual squared. And, oh, I did that wrong. To do that, you're going to do equal sign, sum, parentheses, drag, and then when you let go, it should put that in, click enter, and it'll give you a value. This is what we are going to try to be minimizing. So once you have this all set up, we just want to minimize this sum squared residual by changing A and B. So to do that, we're going to go to the data tab, and then we're going to go to solver. If you don't have solver, you click analysis tools up here, and just, I guess, check mark it, and it'll show up. So we've got solver. And so it's going to ask for our objective. I already had my cursor on this SSR. If you don't, you're just going to type in $, and then whatever cell your SSR is in. And then we are going to minimize it. So we want this to be as close to 0 as we can by changing the variable cells. And then I'm just going to click A and B. Oh, A and B. Drag and drop. It'll give us this. There are constraints you can add. We don't need to deal with that right now. Just click solve. So it'll take a minute. Your computer will have to think. It's thinking right now. And then it'll give you this value. And it'll say solver results, keep solver solution, or take it back. So obviously before we had like 105, now we're at 0.04. That's a lot better than we had. So we're going to click keep solver solution. Okay. And then here you can see our line of best fits are almost exactly on top of each other. And that's what we wanted. So from that, we've got our 2 lines. You can't even tell there's 2 lines. There are. I guess that might be where it would be nice to take the line out so you can see both of them. There we go. One's data plots and one is the line here. You can kind of see it better. Title your chart, add in your axis, and then you've got your A and B values that the solver solved. And that's how you do it.